Hello guys, we will be solving quadratic equation problems today, and we will be solving one tap problem and one train problem from the quadratic equations, which are very important in your syllabus, and I am guaranteeing you that it will come in your exams. So let's start. Let's see what's the problem here. So it's the tap problem. What's the question we will see? The two water taps together can fill a tank in 9 3 by 8 hours. The tap of larger dimensions takes 10 hours less than the smaller one to fill the tank separately. So find the time in which each tap can separately fill the tank. So we will be needing to find out the time of each tap that will fill the tank entirely. So let's start. So first we'll be taking the time of the tap of the larger dimension. So let the time taken by the tap of larger dimension p, let's say t hours. So in the question we have seen that the tap of larger dimension takes 10 hours less than the smaller one. So therefore time taken by the smaller tap equals to t plus 10 hours. Okay, so the tap of larger dimension fills the whole tank in t hours and the smaller tap in t plus 10 hours. So we'll be needing to find the part of the tank filled in 1 hour by each tap separately. So the larger tap will fill equals to 1 by t part of tank in 1 hour. Similarly, the smaller tap will fill in 1 by t plus 10 of part of the tank in 1 hour. So collectively in 1 hour they will fill how much? This plus this. So let's find out this. Therefore in 1 hour togetherly they will fill how much? This plus this apart, 1 by t plus 1 by t plus 10 part of tank in, sorry, we have already written it in 1 hour. So this is the first equation, or you can say first declaration. So we were given another part, that is two water taps together can fill a tank in 9 3 by 8 hours. So we just found out that in 1 hour this much. So in 1 hour how much it will be filling we can find here from also. So according to the question, the taps will fill the tank in 9 3 by 8 hours, which we will maybe writing 75 by 8 hours. So the taps will fill, this will be inverted, 1 by 75 by 8 equals to 8 by 75 part of the tank in 1 hour. Okay, this much is done. So this is will be the second declaration or equation. Okay, so this thing and this thing is now the same, so we may equate these two. Therefore 1 by t plus 1 by t plus 10 from the first one equals to 8 by 75. So we will solve the quadratic equation. First we will LCM these. LCM will be t plus 10, then add these two. It will be t plus 10 plus t equals to 8 by 75, or 2t plus 10 by t into t plus 10 equals to 8 by 75. I am doing right here also, from this line, from up. So it will be, upon multiplying by cross multiplying, it will be 150t plus 750 equals to, I'm multiplying right away. Okay, so rewriting in the correct process will be 8t square minus 70t, we are calculating this, equals to 0, or dividing both sides by 2 now, we will be having this. So you may apply Sridharacharya here or factorization process. We will be using factorization process in this meantime. So upon factorizing, we will be getting, here is 4 and 375, which gives us 1500. Upon factorizing 1500, it's 300, 5, 60 and 5, 12. We can see here 5 into 12, 60, minus 25 will give us 35. So without wasting any time, we will be doing this. 60 minus 25, t minus 375 equals to 0. Now we'll be taking common, 4t square minus 60t plus 25t minus 375 equals to 0. Taking common 4t, if we take common, t minus 15 plus 25, if we take common, t minus 15 equals to 0. Or we will take another common, t minus 15 into 40 plus 25 equals to 0. So up till here is done. So we need to find the process. Find the values only here now. So first one was 40 plus 25 equals to 0, and another one was t minus 15 equals to 0. It's either or, you know. So from here we will finding t equals to minus 25 by 4, which is not acceptable. Not acceptable, since time cannot be negative. Okay, so from here we will find t minus 15 equals to 0 equals to t equals to 15. So this is the accepted one. So therefore time taken by the larger tap equals to 15 hours, and time taken by smaller tap equals to 15 plus 10 hours, that will be 25 hours. So the final answer, the larger tab will take 15 hours, the smaller tab 25 hours. So the next problem, that's the train problem. A train travels 360 km at a uniform speed. If the speed had been 5 km per hour more, it would have taken 1 hour less for the same journey. Find the speed of the train. So we'll be needing to find the speed of the train. So let us start by taking the speed of the train as s. Let the speed of the train be s kilometer per hour. So what's the distance to cover? It's 360 kilometer. Therefore, we know time equals to distance by speed. Time taken to cover a distance of 360 kilometer at s kilometer per hour will be 360 by s hours. According to the question, what it has said is 5 kilometers per hour more, it would have taken 1 hour less. So let's now take it. If the speed of the train had been 5 kilometers per hour more, speed of train would be how much? That is, it was previously s, so it's 5 kilometers per hour more, so would be s plus 5 kilometers per hour. So let's move on to the next page. So then from the new speed, time taken to cover at s plus 5 kilometers per hour will be how much, guys? The same procedure, 360 equals to 360 was the total distance. The distance remained the same, but the speed changed. So it will be this. So according to the question, that it will take 1 hour less if it had moved at plus 5 more kilometers per hour, that is speed. So the equation we may write that the first time minus the second time equals to 1. Understood, guys? So we'll be taking common for efficient solving. Equals to 1, or 360 into, will be subtracting those LCMs will be that equals to 1 s, that is s plus 5 minus s will be cancelled out. 360 into 5 will be 1800 by s into s plus 5 equals to 1. So cross multiplying, s square plus 5s equals to 1800. Taking this 1800 on one side to form a quadratic equation equals to 0. Here also we may use Sridharacharya or factorize method I will be using the factorizing method, or so it's 1800 into 1. Here is coefficient 1 and the constant term is 1800. So 1800, if we do 900, 450, 225, we divided by 3, 75, 15 and 3. Okay, so we might take, that is 2 into 2 into 2 and 1 5. If we multiply all those, we will get 40. Okay, and the rest, if we multiply 3, 5 and 3, that means 3 into 5 15, 15 into 3 45. So 45. So if we subtract these, we will get 5. So we can put it here, a square plus 45 minus 40 is minus 1800 equals to 0. Now factorizing process is going on. Or take in common from both ends, minus 40, it will be 45 equals to 0. Okay guys, so we'll be taking the final common, that is plus 45, s plus 45 into s minus 40 equals to 0. So either and or, so for either we will be having s plus 45 equals to 0 or s equals to minus 45, and for or we will be having s minus 40 equals to 0 or s equals to 40. Since speed cannot be negative, we will consider this one. So the required speed of the train is 40 and its units, it's kilometer per hour. So here's the full sum again. Here's the question. It's a train problem and we have already discussed the tap problem. Hope you like the video. Please like, subscribe and share with your friends. Thank you.